Well, good afternoon. My name is Scott Geis. I'm an integration specialist from the GIS Program Office in New York. And I'm joined today by Michael Minn of the University of Illinois, and he is the creator of the MMQGIS plugin. And we are here today to tell you a story, and it's a success story on creating an effective partnership between a state government agency and an open source developer. And hopefully, you guys can take something away from this and maybe be applicable to some of the work that you're doing. Now, to start this story, I'm going to give you a little bit of a background. For starters, the mission of the New York State GIS Program Office, where I work, is to ensure that authoritative GIS data is available, discoverable, understandable, and easy to use by all. Furthermore, we realize that the ground floor of entry for GIS should be attainable. And what that means is that the cost shouldn't be prohibitive. Nor should the dependency of one software over another be an exclusionary factor for our customer base from being able to use our data. So as an integration specialist, I work to ensure that the GIS products that we offer are usable by everyone, regardless of the software or coding approach that you're using to connect to them. So for more than 15 years, the New York State GIS Program Office has been working to make these two objectives a reality for all New Yorkers. Now, one of the greatest tools that we have to achieve this is we have an authoritative geocoding service, which makes our streets and address database available without a download requirement. So you're not required to download terabytes of data in order to use this. This is a web service that we provide freely that you can tap into and use for geocoding. Our street and address maintenance program maintains the statewide authoritative data set as part of our next generation 911 compliance, and we offer it out to stakeholders for whatever customer activities that they have. But basically what that boils down to is we have a distribution of over 6 million address points generated with rooftop level precision, so the accuracy is very high. This graphic shows a little bit what would come back, the types of hits you would get. We have most rooftops, but you could also get some primary structure, driveway entrance, parcel centroid. But this data, this accuracy is critical to our mission, because whether we're ensuring that a pizza gets delivered to the right location, or we make sure that emergency services reach the right location, we make accuracy a priority. Because the where can't be compromised for either one of those. So what's the problem? Well, this all sounds great. We realized that our geocoding service is an Esri server-based solution, and we realized it was therefore unavailable to a large contingency of our GIS users. It wasn't available in QGIS. Prior to working with Michael, the geocoding services that were available to QGIS were Google, OpenStreetMap, the U.S. Geological Survey, and several other paid-for services. And this is not a knock on any one of those services. And in fact, we are in coordination with many of the groups, providing them updates to address data for New York State. So a lot of those groups use our data. However, we stand by the statement that our services are the most accurate for the state, based on the rigorous process we have for street and address mapping. So internally realizing this, we had to have a conversation on how best to address this and how to approach open source technologies from a government perspective. The blunt truth is that a desire to support open source solutions that can conflict with the dependence of state agencies on proprietary software. This has in fact prevented the GPO from being able to provide this data set into QGIS for our customer base that relied heavily upon it. So what did we do? Well, we had a conversation, and we said, what would happen if we reached out to a QGIS developer of a plugin and said, hey, what would it take for our services to get used in QGIS? And I want to pause on this question for a second, because this is an important question for many reasons. One of these reasons is that it represents an important divergence from traditional thinking that I'm sure many of those in state government can sympathize with. Often we find that state agencies have a single sectored or siloed approach to resource management. And whether those resources are trees or terabytes, we all tend to stay in our lane. and make do with the proprietary software our agencies have provisioned over the years. So we ran into this problem, and we turned to the New York State's Geographic Information Officer, Frank Winters, and he remembered reaching out and meeting a developer at a conference in the past. And so we reached out to Michael, who I mentioned is the developer of the MMQGIS plugin. And I'm not going to do justice to all the nuts and bolts behind it. That's what Michael's going to do later. But basically what it boiled down to is the plugin was the perfect tool for connecting our 6 million rooftop address points and to QGIS and making them available to our constituency. So in the spring of 2019, we reached out to Michael and asked what it would take. We worked through a series of user requirement conversations, testing scenarios. And in the fall of 2019, Michael was able to upgrade the toolkit to be able to use the ArcGIS geocoding API. So I'm going to give a little demo of what this looks like in practical use. And so the first thing you need to know is this is our geocoding URL. And this is what you're going to want to use inside the MMQGIS tool. And so what I'm going to do is I'm just going to run a little video here, show everybody. Okay, so taking that tool, or taking that URL, you would go down to the Find Address Candidates portion of it, which is the Esri supported operation. And I'm just going to take a test data set. This is about 200 records. And you can either use a multi-field approach where you have address, city, state, and zip code all separated out, or I created my own Scott single line approach where I concatenated those into one column of my CSV. So now inside QGIS, if you didn't have the plugin already installed, what you would do is you would go to the plugins, go to the plugin repository and type in MMQGIS, and you would have that available to you. Now I've already got it installed, so instead I'm going to go up to my top toolbar where the annotation MMQGIS would appear. I'm going to go to Geocode and then Geocode CSV with a web service, and I've put that test record CSV up top. And in these next 4 boxes, what you have are entry points where you can put the fields from your CSV in there. Now, those names, even though they say address, city, state, and country, are not indicative of a requirement. You could put any combination in there. For example, I could put zip in the country place, and it will still work because behind the scenes, what the program is doing is it's concatenating those entry points. If you're going to do a multi-field approach, I would recommend setting the state to none, because in New York State, we tend to have we have a major city that's also named after the state, and that does pose problems for geocoding. So I entered a single line, I picked an Esri server, and I entered in that URL from before, down to that Find Address Candidate operation. Now you can choose to use only the first result, the best score returned, or you could have multiple results. Our geocoding service has a number of locators inside it. And what is going to happen in the background is it's going to go through all of those locators and it's going to come back with the best result. And so at the bottom there, I created an output file for my shapefile and an output CSV that would have all of the unmatched records returned. You can see that after geocoding, those records pop up in New York, and if I identify any one of those features, I can pull up the attributes. I can see things like the score that was attached to my successful geocode. I can see which of the locators were used. I mentioned we had a series of locators in our geocoding service. And I can also look at this user ID field, which helps me determine that rooftop address versus parcel centroid versus driveway, etc., that I showed you on that slide before. And so with that, I'm going to let Michael talk a little bit more about the nuts and bolts of his great plugin that we were able to partner with him on.
Excellent. Thank you, Scott. Behind the scenes, the operation of this plugin is actually fairly straightforward. The plugin runs through each line in that CSV file and forms a URL containing a search string, and that format for that API request URL is documented fairly well on Esri's website. Next slide. This is an example of such an API request. If you've never seen one of these things, this is a case for the Empire State Building at 20 West 34th Street in somewhat barren Midtown Manhattan. Note that at the very end, there is this F equals JSON parameter in the URL, which requests that the return data be in JavaScript object notation. You'll also notice that the different fields, as Scott mentioned, are combined into one long search string. The labels that are in the dialog for address, city, state, and country are all recommendations. Usually that it's from experience, that seems to be the thing that works with most geocoders if you can put them in that order. And so rather than just give an ambiguous or force people to do a single string, which obviously in Scott's case, this is something he found that works more effectively. In many cases, when you're using something like the Esri World Geocoder, usually something like what those fields are is enough. Next slide. The geocoder then processes the request and returns the candidate latitudes and longitudes. And this is an example of JSON, which looks a bit forbidding, although it's really quite logical once you know how to read it. Python does have a standard library for parsing JSON, so it can be accessed just like any other kind of hierarchical data structure. Next slide. The points with those latitudes and longitudes are then sent to an output file, which if you know the QGIS API, it's implemented using the QGIS vector file writer class. And that file is then added as a layer to the current map and you're done. Next slide. The toolkit as a whole is about 11 years old. It started when I was first taking my very first GIS class, actually. I went back to school for my second master's degree. My first master's degree is in comp sci. And as is convention, what that class was taught with ArcMap, which presents a multitude of challenges, as most of you are probably aware, on top of just the fundamental complexity of GIS. Since I was then and am now a Linux person, and I have this pathological aversion to technological monopolies of any kind, I asked Johan, my instructor, Johan Albrecht at Hunter College, whether there were any open source options, and he suggested QGIS, which was fairly new at the time. For those of you that weren't around then, or if you're feeling nostalgic for the pre-COVID days, this is what QGIS 1.0.1, what the interface looked like at the time. Those early versions of QGIS had a very limited toolkit, and I specifically needed Voronoi or Thyssen polygons for this class project I was doing. QGIS had and still has an open Python API, so I decided to just roll my own tool, which would also give me a chance to learn Python, which is, of course, the lingua franca of GIS. Next slide. I added a handful of other tools to the plugin, including a Geocoder that used the Google API. And I found out there was this repository where you could share your plugins, so I decided to pay it forward to the open source community and post it there. Over time, people started using the plugin, and I started getting bug reports and feature requests. And so I figured, well, might as well. They like it, they need it, I might as well fix it. And usually the requests were reasonable, so I was able to deal with things fairly promptly. I expected the functionality of most of what was in the toolkit to eventually get absorbed into the emerging processing framework. And they did fork my code at one point, but for whatever reason, the processing developers have never gotten around to putting a web service geocoder into processing. So people keep using the keep using the plugin, and since it's fairly low maintenance, it looks good in my CV. So I just keep doing incremental fixes and enhancements. In that incremental process, the code started to get kind of woolly over a decade. And so I had a major refactoring plan for last summer, which is about the time that Frank initially contacted me from New York State ITS and asked if I could add some support for the Esri geocoding servers. Although the specifics of the Esri API do differ somewhat from Google or Nominatum, which is the OpenStreetMap service, the general control flow is almost identical. And so adding support was fairly straightforward. As I started putting out releases, Scott sent me some additional minor requests, for example, some of those fields that he was pointing out that were useful to them. And I rolled out releases, and over a few weeks, actually, just a month or two, I think, we got pretty much to where we are today. Next slide. In discussing this presentation with Scott, one idea that came up was trying to take some lessons from what we thought, I think both of us thought, was a fairly successful working relationship. And this is what we came up with. First, the QGIS plugin API and the general plugin development environment is very open and bureaucracy-free. Although there is an approval process, from my experience, it's fairly permissive, and anyone that's willing to put in the time to actually post something substantial can usually get it in the repository. Both the QGIS core API and the Qt graphical user interface API present a fairly steep learning curve, but once you're familiar with them, they are fairly intuitive. Second, both ITS and I had a confluence of interest here in an enhancement that would result in generalizable capabilities rather than something that was specific to the case of ITS. My general philosophy with my toolkit has been to include only things that have utility across a wide range of situations and applications. And this Esri geocoder that they were or geocoding service support that they were requesting here fit that bill perfectly. Third, ITS's expectations were very reasonable. It was a straightforward enhancement, and their approach was very low pressure, at least the way they approached me. And finally, this process was indeed iterative. Since I'm a full-time academic, I only have limited blocks of time to work on things like this. And when I made a new release, Scott would send me some notes or requests, and we can make incremental improvements, which is also consistent with the long-term evolution of the toolkit. I'm not sure how much of this can be generalized to other projects. A lot of this was serendipitous confluence here. But we put this out there to give you some food for thought in case it proves valuable to any of you that are working as developers or are working with developers in the future. And so with that, I would like to thank Scott and Frank for reaching out and for their work with me. I'd like to thank Kurt for moderating this. I'd like to thank all of you for attending today, and we're happy to take any of your questions. Thank you.
Thank you.
All right, thanks so much. Well, I'd like to first just say what a pleasure it is to put a face to the name. I've been using MMQGIS for at least 7 or 8 years and teaching with it and everything else. It's a fantastic plugin. So have you had any other experience with other local governments using this this plugin or feeding other Esri geocoding services into this plugin in a similar way?
I'll assume this is for me, not that I know of. I have had interactions in the past with city government people, usually for bug fixes. I've had some feature requests every once in a while, but that was something that was kind of unique about this is that, well, it's actually not, that's not true. Usually the requests I get that again are generalizable are fairly straightforward to deal with, but this was, but I haven't heard a lot of feedback actually for the Esri geocoding. I've heard a lot of feedback for Google, and I've had people, I had a guy, I think just a couple of weeks ago contacted me. He had like 500,000 addresses he wanted geocoding. It's like, oh, can I do that? And it's like, maybe the error the ability to resume, there's nothing like that here. And so that may not be the best tool, but go for it. I'm actually curious to see what happens. But more specifically to your point, at least in terms of other people that would use this with Esri geocoders, I haven't heard any specific feedback yet, but I'd be happy to hear it.
Is that a standard Esri geocoding service that so that the plugin would, if someone had another Esri service, they could probably plug that in and have it work?
Absolutely. It works with the World Geocoding Service. And if you've got it, just like, what Scott set up, I think that's a fairly standard, geocoding API that they've set up on their servers. And you can tell me if that's, and obviously you have to know what you're doing and have to configure it correctly, but the API requests it's well documented. And like I said, this is not rocket science. These things are fairly straightforward. It's a search string and some parameters about once you went back, and it brings it to you.
So Scott, I'm also wondering, I think it's fantastic that you took the needs of your open source GIS users into account during this. And I'm wondering if you have a feeling for how many QGIS users there are out there who would in your service area that would need this.
Yeah, we've started doing some server logs, trying to figure out which applications are hitting it. And we know we have a significant component in the Tug Hill area. We've got a really heavy QGIS user base up there. But yeah, it's something we're looking into now that we are making these kinds of partnerships and really embracing the open source. How do we start to quantify that number and make sure we are reaching all the iterations of people that could be hitting our servers with different software.
A question just came in that says, will you be creating a point geocoder against addresses?
Point geocoder again.
I think that's what you were showing. But,
yeah, so we have, the geocoding service has a street and address database behind it. It returns point locations with a latitude, longitude coordinate, and it comes back with those additional fields that gives more specification on what it's intersecting, whether it's the parcel centroid, whether it's a street line segment, or whether it's an actual rooftop of a building.
Okay.
Scott, is there any throttling? I probably should have asked you this offline. Is there any throttling that you do, or is there any daily limit, or because that's an issue when you're dealing with Google or Noma Native, is that they throttle these things.
Yeah, we have a we're not throttling it, but we have there are some large groups in New York State that can drop significant geocoding requests against it. So off hours are often better for significant large files. I think throughput's anywhere from 750,000 an hour up to 1 million an hour, if I am remembering correctly. But we don't throttle the expectation. We might reach out to folks that are dropping enormous files on top of it and just ask for a little bit more clarity on what they're doing. We have an intake process where we work with groups that have known files of large size to try and coordinate off-hour times that might be better, or at least minimize conflicts.
I also know that there's another geocoding service out there, Peleus Geocoding. And I'm wondering if there's any plans to incorporate that, or if that's even possible at this stage.
I hadn't heard of this before. I'll look into it. I'm making a note right now. And if it's, if it's an API similar to this, it's usually straightforward. If it's more complicated, I'm prepping all my stuff. I've had to flip everything online because of the plague. So we're coming up on the start of classes soon. But I've made a note. Peleus, I assume that's a god of some kind. Anyway.
Yeah. So yeah, let's see, a little clarification on the previous question. The gentleman's asking for local data. So when he was asking about, will you be creating a point geocoder against addresses? He's clarifying for local data and not connected to a service. So you can geocode local street centerline data, but that's not good enough for some applications. So I think he's asking if you can geocode against a street network.
Yes, there is I don't recommend it. I mean, it uses the same kind of geocoding feature layers where you have a start X and an index, and it's the same thing that if you'd done this in ArcMap, it's there. And I think there is some national, somewhere in the government census bureau, I think they have these things, you can download them. So it's there. And if you're doing 500,000 local addresses, probably that may be what you want to do, but it's a little rough. And again, right now, when you're dealing with a resource like what Scott's providing, that's having to do it the old school way. I'm sure there are applications where that's appropriate, but it seems like using APIs is the way of the future. So that's whenever I people, I didn't remember, I got it because I get requests from all over the world. There was a guy, I think in South America somewhere, when you're dealing with the global South, a lot of places don't have a real good cadastre. And so I asked him, why are you doing that? Why don't you just use an API? He said, well, we don't have much coverage in the city that I'm analyzing. So there are cases where it's appropriate.
Well, thank you both very much. It was a fantastic talk, and we really appreciate it.
Thank you.